Exposing the mystery in light. Did you know light can be both a wave and a particle? This dual nature of light has puzzled scientists for centuries. It's one of the most fascinating aspects of quantum mechanics. Imagine light as a chameleon, changing its behavior based on how we observe it. This concept is at the heart of the Double-Slit Experiment, a groundbreaking experiment that has challenged our understanding of reality. Let's uncover the Double-Slit Experiment. This experiment was first conducted by Thomas Young in 1801, and it has since become a cornerstone in the field of quantum physics. The setup is deceptively simple but reveals profound truths about the nature of light and matter. Imagine this: you shine a light through two tiny slits. These slits are incredibly close to each other, just a fraction of a millimeter apart. The light that passes through these slits then hits a screen behind them. What do you expect to see? If light were just a particle, you'd expect to see two bright spots on the screen, corresponding to the two slits. Simple, right? Just two lines of light? Well, think again. Instead of two lines, you see a series of bright and dark bands. This pattern is known as an interference pattern. It's as if the light waves are overlapping and interfering with each other, creating a series of peaks and troughs, much like ripples in a pond when you throw two stones close together. In the double-slit experiment, light creates an interference pattern, kind of like ripples in a pond. This shows light acts like a wave, but how can light, which we often think of as particles called photons, create a wave-like pattern? This wave-like behavior of light was one of the first clues that light isn't just a stream of particles. It behaves like a wave, spreading out and creating interference patterns. This dual nature of light is one of the key principles of quantum mechanics. But hold on, it gets crazier. When scientists shoot individual light particles, or photons, through the slits, they still form that same interference pattern. Say what? This means that even when photons are sent one at a time, they somehow interfere with themselves, as if they are aware of both slits. It's like the photons know where the slits are and behave accordingly. This phenomenon is known as wave-particle duality, and it's one of the most mind-bending aspects of quantum physics. It suggests that particles can exist in multiple states at once, a concept known as superposition. But here's the kicker. If you try to observe which slit the photon goes through, the interference pattern disappears. Poof! Just like that. This is known as the observer effect. The very act of measuring or observing the photon changes its behavior. Now light acts like particles again. This means that the photons are no longer creating an interference pattern but are instead behaving like individual particles, hitting the screen in two distinct spots. This change in behavior based on observation is one of the most perplexing aspects of quantum mechanics. So what does this all mean? The double-slit experiment shows that observing something can actually change its behavior. Mind-blowing, right? This experiment has profound implications for our understanding of reality and the nature of the universe. It suggests that at a fundamental level, the universe is not deterministic. Instead, it is probabilistic, meaning that particles exist in a state of probability until they are observed. This challenges our classical understanding of physics and suggests that the act of observation plays a crucial role in shaping reality. The double-slit experiment shows that observing something can actually change its behavior. Mind-blowing, right? This experiment has profound implications for our understanding of reality and the nature of the universe. It suggests that, at a fundamental level, the universe is not deterministic. Instead, it is probabilistic, meaning that particles exist in a state of probability until they are observed. This challenges our classical understanding of physics and suggests that the act of observation plays a crucial role in shaping reality. Physics isn't just about boring equations. It's about exploring the mysteries of the universe and uncovering the fundamental truths that govern our reality. The double-slit experiment is a perfect example of how a simple experiment can reveal profound truths about the nature of light and matter. It's full of mysteries that can leave you scratching your head and saying, "Whoa!" The more we learn about the universe, the more we realize how much we don't know. Each discovery opens up new questions and new avenues of exploration. Stay curious and keep exploring the wonders of the universe. The double-slit experiment is just one of many fascinating experiments that challenge our understanding of reality. Who knows what other mysteries are out there waiting to be discovered? The journey of exploration and discovery is never-ending, and it's what makes science so exciting.